All right, next question. On Earth, a parallel of latitude is a circle parallel to the equator. So if the equator cuts the Earth in half, and you kind of like imagine that the Earth's getting sliced into disks, those are your parallel of latitude. The 35-degree parallel latitude means that if you go into the center of the Earth and you have a 35-degree angle of elevation, this line where that radius hits is your 35 degrees. So this is what it would look like if we were, I guess, looking at exactly the side. Cut the Earth in half from north to south and look at it from the side. So this is the center of the Earth. From the horizontal, it's an angle of elevation, excuse me, of 35 degrees, which means that if this goes all the way to there, it's the same as the radius going from all the way to there. So, okay. And then where this hits, that's the 35-degree parallel line. Okay, so find the length of the 35-degree parallel of latitude to the nearest 10 kilometers. Assume that the radius of the Earth is that. So I'm not going to lie. Even though we do these every year, sometimes I look back at stuff because I've been doing other things and I'm like, okay, what is this asking again? How do we approach this? This question wants to know the length of that. Okay. So my first thought was automatically like radius, diameter. Maybe that's how I have to work with, like, to find this answer. But because this parallel is not going through the center of the circle, the radius and the diameter, like I can't just like divide this by 2 or something to make the radius and diameter. So that idea's out. Then I thought of trying to create some right angle triangles because I mean we're in a right angle triangle unit. So I was like, all right, this is the radius, and boom, let's drop this down right there. Look at that, I made a right angle triangle. And I know that this is 90, and this is 35, and this is the radius, so I could find this height, but that doesn't do anything for me as far as this line is concerned. It's absolutely a correct move, but it doesn't help me solve this question. So then I went back to the drawing board and I said, well, what's true about these lines? They're parallel. What's it? Oh, there goes my microwave. Sorry, I'm gonna have to pause. This is awful. I hate real life. Parallel lines have specific relationships. So if we're thinking back to grade 9, there was the F, the C, the Z pattern. So if we use the Z pattern right here between these parallel lines, this angle is going to be the exact same as that angle. Which I thought about and I saw, and it didn't immediately make sense to how I could go forward from here. But then I took a little bit longer and figured it out. So we are going to use the Z pattern. We're going to use the Z pattern, and we're going to recognize that this angle right here is also 35 degrees. Now, if I do my previous plan to create a right angle triangle, but I go, sorry, this way, now I have a SOHCAHTOA triangle because I know that the radius, which is the same as the hypotenuse for this triangle that we've created, is 6380. I have a given angle within the triangle, and then if I'm solving for this side length, I would just have to multiply it by 2 to find out the length of the entire thing. So that's where that took a little bit of thinking, I'm not going to lie. Like, I looked at this before I did my video and was like, all right, let's think this through before you make an idiot of yourself. So here we go. there. So there's our triangle. And it looks like it's an equilateral, or there. It's just there. Okay, perfect. So we know that this is the 90 degrees. We're trying to find this side. We know that this is 35 degrees, and the hypotenuse is 6,380 kilometers. Okay, so based on this, label your sides. We know this is height. I have a frog in my throat. I am so sorry. We know that this, based on the angle, if we go across from it, this would be the opposite side. So this is our adjacent side. Then we think of SOHCAHTOA. So, CAHTOA. And we look for the relationship. Because we're looking for x, we need the adjacent. And because we were given the height, it's adjacent and height. Which of these are adjacent in height? Cos. So, cos of the angle is adjacent, we don't know that side, over the hypotenuse, which we do know, 6,380. Okay, do a little bit of math on this side. Some people just might want to like multiply it by 6,380 times cos of 35 all in one step, and you can do that. I'm just showing the middle step if students like more steps in their solutions. And some people do. Like, I'm one of those kids. Okay, so 0.8192 equals x over 6,380. And then we're going to multiply both sides by 6,380. Boom, boom. And we get our answer for x, which is 1 of the times 6,380, which is 1 of, excuse me, I'm so sorry. Okay, it's not COVID, it's allergies. Here we go. 5226.19 equals our final answer. And that is only one part. So if we double it, we're going to find how long the 35th parallel is. So we'll take 2 times 5226.19 equals length of 35th parallel. Okay. And then we go times 2. 10,425, 10,425.38 kilometers. Length of 35th parallel. So that means the equator is, let's double the equator. This has nothing to do with, like, we're done with the question. But let's double the equator, because 6,380 times 2. So the equator is 12,760 kilometers across, and the 35th parallel is 10,000 kilometers. That's such a big number. Cool, cool, we did it.